Hi everyone. Last time we worked at the first half of 4.6 and we talked about how to solve a quadratic equation by taking the square root of both sides. And we had these wonderful perfect square trinomials that we were able to do that with. And this was an example of one that we did last time. This factors down to be x minus 7 times x minus 7. And then this factors down to be positive or negative 5. And we were able to solve that way, which was great. However, not all equations factor so beautifully, wonderfully. And I want to teach you how to change equations around so that they will. So that if you don't have this perfect square, you can make it so that it will have that perfect square. And I'm going to show you how to do it. And it's not as hard as you might think. Okay, remember I showed you that this factors to be x minus 7 times x minus 7. And we found that because 7 times 7 is 49, and negative 7 plus negative 7 is 14, and that's how we knew it was x minus 7 times x minus 7. What I want to do is say, let's say we don't know what this number is. We want to figure out what would that number have to be. This is our first step in doing the process called completing the square, is we need to determine what this number would be. And so what we do is we take this b term, in this case, it's negative 14, and we divide that term in half. So it becomes negative 7. And then we take that negative 7 and we square it. Negative 7 times negative 7 is positive 49. And now this factors to be x minus 7 times x minus 7. This number ends up being half of that. So what we're going to do, we're going to practice what would C be. So step 1, take B, divide it in half, and then square it. Here's one, x squared minus 10x plus what? What would we have to add to this for it to be a perfect square? Well, take negative 10, divide it in half. What's half of negative 10? It's negative 5. Okay. Now take that number and square it. What's negative 5 squared? Positive 25. So C is 25. By the way, these will always be positive. Because it's a perfect square, the signs are going to be the same, so you're not going to have a negative. You're always going to be adding something. In this case, it's 25. After you do this a few times, you can do it very quickly in your head. X squared plus 6x. Now what is it? Okay, what's half of 6? That's 3, square 3, and it's 9. And this will factor to be x plus 3 times x plus 3. The explanation in your book doesn't show what to do when this is odd, and I think it should. So let's make this an odd number, because now when we want to find what half of that is, we have some choices, don't we? So we can either deal with fractions or decimals. Either one is fine. I prefer fractions. Fractions are way better, trust me, way better. But I know some of you really don't like it. But half of 5, my way, would be 5 over 2, right? If you did half of 5 a decimal, it would be 2.5. Now when we square that, this becomes plus 25 over 4. You just square both numbers, 25 over 4, and you're good to go, all right? That's all you have to do. And this 2.5 squared times 2.5 squared, I'm not sure what that is, 6.25, something like that. Whatever that is, that's what you would add. But that's how you deal with it when it is an odd number. Just to help you with fractions, what if you had something like this? You won't. Trust me, at least I don't think you will. But first step is I have to find half of 1/3. Half of 1/3. So it's not that hard. You just multiply it by 1/2. 1/2 of 1/3 is 1/6. So that is 1/6, and you square 1/6, and it's 1 over 36. Crazy, isn't it? But think about it. That means this would be x plus 1/6 times x plus 1/6. 1/6 plus 1/6 is 2/6, or 1/3, and 1/6 times 1/6 sixth is 1 over 36. So even that crazy number, it still works. Okay, now we are going to do the meat of this program, which is solving an equation by completing the square. So here's an equation. We are going to solve for 0. We're going to use the method of completing the square to solve it, and here's how we do it. First thing is this has to be just an x squared in order to square root this side. That means I have to divide by 3. Because this is an equation with an equal sign, I can just divide the entire thing by 3. I don't have to factor the 3 out. So I'm going to divide every single term, I'm going to divide by 3. So divide by 3, divide by 3. So I get x squared minus 4x plus 2 equals 0. And sure enough, this is not a perfect square. But I want it to be. So what I'm going to do is I'm going to get rid of this 2. I'm going to take it out of my way. I'm going to move it to the other side. Right? So now I'll have x squared minus 4x. I'm going to leave my space, and my positive 2 became negative 2 over here. See that? Now, what do I add? Do the same thing we just did. Half of negative 4 is negative 2, and negative 2 squared is positive 4, so I'm going to add 4. And you may think, what do you mean you're going to add 4? How can you just add 4? But don't forget, you can do anything you want to an equation as long as you do the same thing to both sides. Since I added 4 to this side, I need to add 4 to this side also. Now my equation is still equal and it's all fine, right? Now I can factor this. This becomes x minus 2 squared. X minus 2 times x minus 2. Nice. I have my perfect square trinomial, just what I wanted. This simplifies to be positive 2. Now I am going to take the square root of both sides. So this is x minus 2 equals plus or minus the square root of 2. And my last step, to solve for x, I need to add 2 to both sides. It's going to become positive 2. There's my answer. I do not mind if you want to leave it in that format. So my x is 2 plus the square root of 2 and 2 minus the square root of 2. 2 irrational answers for this problem. Okay, here's a problem I want you to practice. 2x squared minus x plus 3 equals x plus 9. What do you have to do to this in order to solve it by completing the square? So pause the video and try it, work it out. Then you can restart the video and I will walk you through this and we'll see how you did. Okay, so first you should have moved this x over with this one. So now we have 2x squared and minus 2x. And I'm going to go ahead and move this 3 over here equals 6. 9 minus 3 became 6. I didn't show the minus 3's and the minus the x, but hopefully you can see it. I can't have this 2, so I'm going to divide everything by 2. This becomes x squared minus x, and this becomes 3. Everything gets divided by 2. Now I have to add to both sides, and this is negative 1. What's half of 1? It's 1/2, right? What's 1/2 squared? 1/4. So I'm adding 1/4. Oh my. This factors to be x minus 1/2 squared. If you put 0.5, I won't quibble with you, that's fine. And this becomes 3 1/4. Or, I like improper fractions. I'm not going to write 3 1/4. I'm going to change that to the improper fraction 13/4. 4 times 3 plus 1, right? Do you remember that? So that's 13 over 4. Now, I'm going to square root both sides. So this becomes x minus 1/2 is equal to plus or minus the square root of 13 over 4. I'll just leave it like that for right now, but I'm going to simplify this. bring over my 1/2. So x equals 1/2, brought it over, plus or minus the square root of 13 over 4. By the way, this is the same as the square root of 13 over the square root of 4. What's the square root of 4? Let me show you this. The square root of 13 over 4 is the same as the square root of 13 over the square root of 4. What's the square root of 4? It's 2, isn't it? So, plus or minus the square root of 13 over 2. All of this is over 2. You can totally leave your answer just like that. Or, because they have the same denominator, you can actually combine it. That's kind of cool. So x equals 1 plus or minus the square root of 13 over 2. These are the same. And either one is fine with me. That was complicated. If you got it right, bravo for you. But I really had to walk you through this. Okay, now the last step we're going to do is where it's not a straight equation, it's just in a function form. Y is x squared plus 4x minus 6. And I want to change this from standard form to vertex form. I showed you one way to do it earlier, which was actually simpler. The negative b over 2a is your x, and then you found your y, and that became your hk. Do you remember this? Because vertex form looks like this. This is what we're going for. And so what we did is we found hk by using negative b over 2a for my x and plugging that in to get this y. And then we used the same a, and that's an easier method. But I want to show you how you can go from here to here using complete the square process. Okay, so here's how you do it. We're going to go do the same type of thing, except I really don't want to mess with my y. There's not a number here. I can, but I don't want to, so I'm going to show you where you don't have to. I'm going to just move this negative 6 over. In fact, rather than take up board space, I'll do that now. Just going to move it over here. Now it's out of my way. So now what do I need to add? What's half of 4? That's 2. And 2 squared is 4. So I need to add 4, right? Plus 4. Now, normally, I would add 4 to both sides, which I can do. But then to get y by itself, what would I have to do to move that 4 back over? I'd have to subtract the 4, right? So I'm just going to do that, and then I want you to notice what I just did. If I added 4 here and subtracted 4 here, the net result is that I have added a big 0. I have not changed this side at all. At least not, you see what I mean? So this is what I need to do. Instead of adding the same amount to both sides, I'm going to add and subtract the same amount from the same side so that my net result is 0. And now I just simplify this and I'll be done. It's that simple, which is nice. So y equals, this factors down to be x plus 2 squared, x plus 2 squared, and that simplifies to be minus 10. And that's in vertex form. That's all I had to do. Now, what's the vertex? The vertex is negative 2, negative 10. Do you remember how we did that? Opposites. There we go. And I think that's all it asked for. Let me check. It also asked for the y-intercept. So we have our vertex here. And remember that the y-intercept in standard form was this. So I think our y-intercept then is just negative 6. We should have looked for that first, because that was our original c when it was in standard form. And there's our y-intercept. And we've finished that one. Let's practice another one. Here's our got it example. What I want you to do is I want you to put this in, what is this in vertex form? So change it to vertex form. Then what's the vertex and what's the y-intercept? And then come back and check your answer. Okay, so first, before I do anything else, I know that my c is my y-intercept. So I am going to make this 0, negative 6, and do that first right off the bat. Now I'm going to scoot this negative 6 over. And now I've got one of those odd numbers. So half of 3 is 3 over 2, and that squared is 9 over 4. I have to add 9 over 4, which means I'm also going to subtract 9 over 4, okay? You might think, Mrs. K, you're crazy to do fractions, but I like fractions. Okay, now I'm going to factor this. This becomes x plus 3 over 2 squared. Notice in the factors, this is half of that, and with that sign. There we go. So y equals that. And since I'm going to combine these, I'm going to change the 6 into fourths. 6 times 4 is 24, so this is negative 24 over 4, right? Now I can combine them. Negative 24 and negative 9, this is negative 33 over 4. So what's my vertex? My vertex is, this is my x, negative 3 over 2, and my y is negative 33 over 4. And even with a gnarly numbers like that, this still works. I want to give you a problem that has a number in front here to show you how to do that, and I still need to give you your lesson check for today, so don't stop now. Okay, I want to show you how to rewrite this in vertex form. It looks complicated, but it's not as bad as you might think. So the first thing I want to do, I want to move this 1 just out of my way. I'm just going to scoot it over. And remember, I can't have that 2 there. But this is not a number where I can just divide. I can't divide y by 2. So I can't divide it out. I'm going to factor it out to the left. So this is going to be part of my trinomial, right? So I'm going to pull the 2 out. So y equals 2, and this becomes that. Do you see how that works? I pulled the 2 out of both of those, but I didn't pull it out of here, so that's still plus 1 because it's outside of the parentheses. Now what do I add? Half of 4, negative 2, that squared is plus 4. So you might want to automatically think, oh, I added 4, now I have to subtract 4, right? Wrong. Oh, this gets so many students, but not you, because I did not add 4. I added 2 times 4. I added 8. Be careful because of this. I actually added 2 times 4, or 8. That means I have to subtract 2 times 4 or subtract 8. Be careful, that'll get you. Okay, now I can factor this. So y is 2. This is x minus 2 squared. And this is minus 7. There you go. And so now we have an a of 2 here. And our vertex is 2, negative 7. That's how to do it if you have a coefficient other than 1. And this is the critical thing that most students miss, but not you. The lesson check is easy. I needed to be easy on you after that hard lesson. What does C have to be in order to complete the square? That's all. Just what number would you have to add to make this a perfect square trinomial? You can see now why I split this section into 2 parts. So have fun with this completing the square, and I will see you guys next time.